calculator for p-val, because in your z, you can look it up in your table, find your z-score, find your corresponding area, which is your probability value, but your t doesn't have that with the chart. Your t only gives us the level of significance and the value for t. We don't get an area for that. We can approximate it, but we can't get exactly. So therefore, what we're going to do is use your calculator for your p-val for that. You can use that table and come in between a couple of them, kind of, and figure out where the top part is for the area, but it's much easier just to use your calculator. So the first one said, an oven repairer says that the mean cost is less than. So mean less than 100. There's his claim. You work for the repairer and you want to test this claim. So here's your sample information. Here's your sample. You test what he says about the population with your sample. So you pull out your sample information. Always pull these things out. It makes it so much easier. Here's my sample. So now I know exactly where my sample came from. Look at N. N is 5. You only did 5 of these things. That's your small sample. They should tell you that this is also normally distributed, but maybe I didn't write it down. So you sample this, and you want to know if you have enough evidence to support, which tells you that was an HA. And you work for this repairer. You want to agree with what he has. You want to be able to support it. If you didn't work for him, you worked for someone else, you'd want to reject his. So this kind of all fits in. So you get your claim, and that also gives you left tail test. Find your cutoff. Remember, table 5. Degrees of freedom, 1 tail, 0.01. That's your cutoff. Can everybody find the critical value for your cutoff?
Isn't it 4?
No, that's your test statistic.
Oh, I got 4.604.
Did you do your degrees of freedom? 4?
Wait.
Right. So did you guys get 4.604?
No, I got 3.74.
That's what I got.
Okay, hang on. Let's take a look at this. For a test. Okay, 1 tail, 0.01. They give you a 1 tail and a 2 tail. Now, again, that was a good thing to notice because the 2 tail automatically splits that, ladies, automatically splits it in half for you. So now, reject H0, that's your shaded part. This is your fail to reject. H0. So now, do your test statistic. Your test statistic is the same as we did for your Z. Okay, because it's a sample, we have to divide by the square root of n. So you find your test statistic, and it falls in your reject H0. This is your decision. So when I ask you to test and state your decision, test, decision. This is your interpretation. My claim was my HA. My decision was reject H0, which means I don't want the no. I want to support my claim. So there is enough evidence to support the claim that the mean repair cost is less than $100 at a level of significance of 0.01. He wants to support what the person he works for is saying. Questions? No? Okay. All right. Next one. We have an environmentalist estimates the mean waste is more than 1 pound. That's the claim. So its alternative one, the complement would be the HO, which is less than or equal to. Follow the tail of your HA. Find your cutoff, 1 tail at 0.05. Your sample was the size of 12, so you're going to do degrees of freedom 11. Everybody can find that cutoff. Since it's on the right-hand side, it's positive. Do your test statistic. Now, you can absolutely use your calculator. Stat, test, and go to t-test. This will give you this information right there. So it falls in your reject H0, that's your decision. Your interpretation is, since your claim was your HA and you rejected H0, you must like the claim. So there's enough evidence to support your claim at a level of significance of 0.05 that the mean waste is greater than 1 pound per person per day. Sounds kind of gross. I know. Okay? Okay. And the last one for your reject region, you had to put in your calculator. So you do your 1 var stat, and since this is your sample, you do your sample mean and your SX, your sample standard deviation. Don't pull out your population because this is your sample. So pull out your information. Again, we test, what was the test? And the claims that the mean is, so it's equal to, there's a two-tailed test. Now, when you find your cutoffs, this time use your two-tail. It automatically divides it in half. You don't have to divide anything in half. So you have a positive and a negative because your curve is symmetric. So you have two places to reject this in. Do your test statistic, it falls sort of in the middle. So you fail to reject H0, and you say, if your claim is your HO, and you fail to reject your HO, that means there's not enough evidence to reject this claim that the mean is 22,300 for your annual salaries at a level of significance of 0.05. Okay? Kind of the exact opposite of your confidence thing. Where we had to say I'm 99% confident, this is like the flip side of it. I'm going to allow a 0.01 chance of error if I'm 99% confident. So if this was, say, 0.05, they're going to be 99% confident that it falls in here. 5% of it will share the reject part. Yes?
So how do you know whether to use the T-score or Z-score?
The T is because our sample size is less than or equal to 30.
Oh, same as the old.
The same as the old. And the population standard deviation is not known. It still follows that concept of that flow chart. And we really never know the population standard deviation because we're always using our sample to test. So this tells us t-test. Now the last three, I wanted you to use your p-test. Again, make sure you put it in your calc. Give me your SX, your sample standard deviation. Your claim was that you randomly select 20 teenagers, and that's your sample. And you want to know, do they drink fewer? Fewer is less. Fewer is less than, but not less than or equal to, because you want fewer. So that's your claim, and your H. Oh, there's no reject region here this time, because you're going to test with your p-val. You have to put this one in your calculator. This is the one you have to use some kind of a program for this one. And we find our p-val in our calculator to be 0.130. We test that against, test always in this order. So put your p-val, put your level of significance, and fill this in. So now you can say 130 is greater than 50. Easiest way. Take the decimal away when you compare the numbers. That, according to that chart, tells you to fail to reject H0. So we failed to reject H0, the rest of it's the same. If the claim was HA, and we failed to reject the null, that means we can't support your claim because we got to go along with the null. So there's not enough evidence to support the claim that the teenagers drink fewer than 12 ounces of soda per day. Pretty sad, too. Another sad statistic. And since this is old, I'm sure this has increased anyway. This is more. Okay, so what did you put in your calculator? Do you have the same values that I have? Let me see. Okay, your claim is wrong. Your claim says less than 3, first of all. Your claim is wrong. So you must have put your mean in at 3. You put your mean in at 3. The population mean should be 12. Oh, no, your mean is 3. Okay, now you can do it. Guys, just so that we all stay on the same page. Okay. A company that manufactures school supplies says that teachers spend a mean of greater than, there's your greater than, 580 of their own money on school supplies each year. A random sample says that 24 teachers, this is your sample, this is what they spent in a year, so you're going to have to do your L1, find your mean, find your standard deviation, or just go to the stats part of that, and it should slide that in for you. But make sure you tell me what test you did. And use your p-val, test against. Now notice, when we test this one, fill it with zeros. 38 is less than or equal to 50. That's your reject H0. So it doesn't matter which side it falls on, when your p-val is less than your level of significance. So there is enough evidence to support the claim that they spend more than $580 of their own. Between pencils and tissues, I can guarantee you this is true. Okay, and I think that is it. Nope, one more. Okay, the dean of a university estimates that the mean is, there's your equal sign, there's your two-tailed test. We don't even care about the two-tailed test. We plug it in your calc, your values, get your L1 going, get your mean and your standard deviation, and come out with your p-val, and that's greater than 0.01. So there's not enough evidence to reject the claim. Just make sure you get the claim and the complement down pat. You need to state which one is the HO. You need to state which one is the HA. Okay? Do you have any questions? What is your claim? Okay, let's see.
No, it says
It's at least.
94 cents greater than.
What's at least? Think money in your pocket. Greater than or equal to. This is the claim. Is this the HO or the HA? What's the HA? What tail test do we have? Right, left. Reject H0. Fail to reject H0. We need to find your critical value. Inverse norm.
Yeah, it's a right sound.
You got to follow the HA. You always follow the HA. Chances are, if you use your calculator for this, you're going to know immediately because your statistic is going to come on the opposite side. Your statistic should come close to your reject region, but there are a few problems where they have messed it up a little bit. But if your statistic comes on this side, go back and look at your tail test. It's probably off. So what is this inverse norm 0.02 divided by 2? That's because we have to divide this by 2 and share it this way because remember, it's technically saying 98% fall in the middle. So we want to know what is this cutoff value over here. Okay, there's your cutoff. Now that's your critical value. That's your cutoff. Remember what we do for the z-test. So now, find your sample information. You have a sample size of 103. You have a mean of 93.5. and you have a standard deviation of 30. So here's your z-score. Look, you're going to get a negative, and you should because it's on the left-hand side. Anybody come up with a z-score? Negative 0.169? Okay, so where does that fall in? Fail to reject is 0. Okay, this is the part that you probably have to remember the most for your z-test. Everything else fall into place.